This module will introduce you to the work in hazardous areas. After completing this module, you will be aware of the risks involved when working in hazardous environments, informed about the basic handling of toxic and flammable gases, informed about the installation requirements in hazardous areas, able to understand the basics of explosion risks, enabled to read and understand the markings and signs of various hazards. The first hazardous location was in early coal mines, where there was the double hazard of methane gas and coal dust. When methane was ignited, it was usually followed by a much more violent dust explosion. In September 1921, 4,500 tons of ammonium nitrate destroyed a fertilizer plant in Ludwigshafen-Oppau in Germany. 565 people died and more than 2,000 were injured. Nearly all the buildings in Oppau and the neighboring towns were destroyed. Exactly 80 years later, in September 2001, history repeated itself in a similar plant in Toulouse. The northern part of the site was devastated.
When an explosion occurs, combustible materials that are finely distributed in the air are ignited. The entire volume of the combustible material reacts suddenly. This results in a sharp increase in pressure and temperature and a corresponding release of energy. Explosions involving solid particles are known as dust explosions. Examples are explosions of coals, paper dust, or even flour. Gas explosions involve the ignition of gases, vapors, or mists. These include, for example, propane, petrol vapors, or hydrogen.
Potentially explosive atmospheres can be found in a wide variety of sectors in modern industry, particularly in the chemical industry. An explosion occurs when three things come together. This is referred to as the ignition triangle. 1. There is oxygen or air in the atmosphere. 2. There is a flammable substance present, either in the form of a gas, steam, vapor, or dust. And 3. There is an ignition source in the form of a spark or a hot surface. These three things must combine. If any of these three things is missing, there can be no explosion. In order to protect people, the environment and facilities, suitable steps must be taken to prevent explosions. There are guidelines for this which go far beyond the scope of the individual company. Founded in 1906, the International Electrotechnical Commission, IEC, is the world's leading organization for international standards for all electrical, electronic, and related technologies. The IEC has defined worldwide standards for hazardous areas and equipment. The 60079 standard, Electrical Apparatus for Explosive Gas Atmospheres, specifies the general requirements for construction, testing and marking of electrical apparatus and components intended for use in explosive gas atmospheres. Different national and international standards are derived from the IEC standards. Their certificates enable us to operate on a worldwide basis. In Canada, CSA. In the USA, FM. In Europe, ATEX. In China, NEPSI. In Australia and New Zealand, SAA. In Russia, the Ukraine and Kazakhstan, GOST. Let's have a more detailed look at the European regulations, which are regarded as the most exact implementation of the IEC standards. The ATEX directive, ATEX stands for Atmosphäre Explosible, is a set of European regulations for equipment in potentially explosive atmospheres. The greater the likelihood of an explosive atmosphere, the higher the stipulated degree of protection for the equipment used in that zone. Depending on the level of protection, equipment is classified in different categories according to the level of protection. Device Class 1 comprises equipment for use in coal mining, where the risk is from methane and flammable dust. Device Class 2 applies to equipment for use in the remaining zones, which might be at risk from a potentially explosive atmosphere, for example from gas, vapor or mist in refineries, chemical plants, gas and oil supplies, and tank farms. The degree of risk depends on different factors, and these are dealt with in the following classifications in the ATEX directive. There are classifications for zones, for gases, and for temperatures. In the following slides, we can examine these three areas more closely. The first classification defines the zones. The action taken to avoid an effective ignition source depends on the likelihood of an explosive atmosphere occurring in areas in which an electrical facility is operating. As a result, these areas are split into zones depending on the level of risk. There are different zones: 0, 1 and 2 for areas where gas, vapor or mist mixtures can develop, and zones 20, 21 and 22 for flammable dusts. A hazardous explosive atmosphere can occur in the zones as follows. In Zone 0, continuously, frequently and over long periods. In Zone 1, under normal conditions but only occasionally. In Zone 2, seldom, for short periods and under fault conditions.
In some cases, it is not possible to prevent the occurrence of potentially hazardous atmospheres at the workplace. In accordance with European Directive ATEX 137, these explosive areas, which may be present in rooms or even in items of apparatus, must be subdivided into different zones, and appropriate measures must be taken to prevent the presence of sources of ignition depending on the danger posed by each of these. This zoning is performed as a function of the frequency of occurrence and duration of such hazardous atmospheres, and is defined separately for dust and gas explosion hazards. In no-risk areas, there is no risk of an explosion under normal conditions. In a Category 2 or 2.2 zone, there is a small risk that an explosive atmosphere may form, while in Category 1 or 2.1 zones, the risk is significantly higher. In Category 0 or 2.0 zones, the risk of explosion is either permanent or may be present for a long period. Hazardous areas must be identified by warning signs and possibly also by floor markings. It is particularly important to ensure that no non-explosion-proof equipment is introduced into these zones. This requirement also applies to industrial trucks and tools.
In North America, hazardous locations are separated into three classes or types, based on the explosive characteristics of the materials. Class 1 covers flammable gases, vapors and mist. Class 2, combustible or electrically conductive dusts. And Class 3, easily ignitable fibers. The class or type of material is subdivided into divisions, based on the risk of fire or explosion posed by the material. The division system has only 2 levels of hazard, whereas the zone system has 3. Division 1 locations, where ignitable concentrations of flammable material can exist under normal operating conditions, frequently for repair and maintenance reasons. Division 2 locations, where ignitable concentrations of flammable material can exist under abnormal operating conditions, or which are adjacent to Division 1 areas. For an assessment of the explosion risk, the employer has to provide classification of areas where hazardous explosive atmospheres may occur, performance of a hazard analysis for the operating area, explosion protection document, regularly updated in accordance with ATEX 137. In cases where process gases are measured, one must bear in mind the risk of an external explosion created by the ambient atmosphere, and also an internal explosion risk created by the sample gas, for example in a gas analyzer. Some measuring equipment also needs auxiliary gases such as hydrogen or ozone in order to operate. Leakages in these circuits can lead to additional explosion risks or toxic hazards.
The definition of the zones is an important part of the comprehensive risk assessment, which contains as well all the necessary protection measures. Approval procedures, as well as identification and security procedures, lockout, tagout, constitute important organizational measures. These set out in writing how hazardous operations in explosive areas are to be performed. You must never work without these approvals and must adhere strictly to the instructions they contain at all times.
The equipment intended for use in hazardous areas is classified according to the maximum surface temperature in the event of an error, at an ambient temperature of 40 degrees Celsius, 104 degrees Fahrenheit, or deviations if these are specified. There are 6 different temperature classes. Each temperature class defines the maximum permitted surface temperature of an apparatus. Since different mixtures have different ignition points, by using the temperature class, it's possible to determine which equipment can be used with which explosive mixture. The ignition temperature of a combustible gas or liquid is the lowest temperature at which the ignitable mixture can explode. The maximum surface temperature of an electrical apparatus must always be lower than the ignition temperature of the gas or vapor-air mixture it is to be used with.